Miss Khadija, are you available?
Yes, ma'am.
So are you ready for your sharing the screen and presentation?
Yes.
Please go ahead without any further loss of time. Please present your screen.
Is it visible, ma'am?
Yes, visible. So you have 10 minutes time. Please start your presentation. Go ahead. Over to you. Start your presentation.
Okay. Myself, Khadija. I'm a final year undergraduate student of Adi Shankara Institute of Engineering and Technology. Thank you for inviting me to Symposium. It was an excellent event, and I truly appreciate the opportunity to be part of it. Smart Fall Detection Jacket for Elderly is a group project that I have done in college, and these are my team members, and done under the guidance of Dr. Teresa Joseph and Dr. Ramya George. Imagine a world where the fear of falling is no longer a daily concern for our elderly loved ones. Falls are one of the leading causes of injury and hospitalization among scenarios, impacting their independence and quality of life. But what if we could provide them with a reliable safety network, one that not only detect falls but also protect them from injury? Today, we will explore a breakthrough solution, the Smart Fall Detection Jacket, combining advanced sensor and protective technology. This jacket is designed to detect falls in real time, send alerts, and provide immediate protection, offering peace of mind for both the elderly and their caregivers. The global aging population face a critical challenge, that is fall. The consequence of fall extend beyond physical injuries, leading to psychological trauma and fear of falling that can limit self-confidence and motivation for independent living. This often results in reduced activity, further loss of strength, flexibility, and mobility, thereby increasing the risk of future falls. While various fall detection systems currently exist, they often exhibit significant limitation in terms of accuracy, affordability, like wearability and real-time response, etc. For instance, false alarm triggered by everyday activities can undermine our user confidence and trust in these systems. So the main thing motivated us to do this project is a growing threat of falls, the accelerating aging population, intensify the concern over falls, and which is a major injury that the elder face. And the other thing is the limitation of existing solution that we have already discussed about the expenses, hindering widespread adoption, etc. And so here I'm introducing advanced sensor technology and embedded system like ESP8266 and MPU6050 sensor. These compact and affordable components hold the potential to create a reliable and cost-effective fall detection system for a vision for a better future. So these are the main objectives that have gone through. The first thing is the innovation of fall detection system using the microcontroller and MPU6050 motion sensor. And here we are developing an airbag system that deploys upon when a fall is detected. And the third thing is when the fall is detected, the corresponding location of where the fall has happened is corresponding location is obtained to the caregiver. And the fourth one is to develop an alert system that will also a notification message will send to the caregiver's mobile number. And the last one is to develop a deflate airbag system to ensure comfort and prevent prolonged pressure. That is, when the fall is detected, the prolonged pressure on the user body will cause severe impact. So here we are developing a deflate airbag system also. And this is a problem statement to develop a system that accurately detects fall using advanced algorithms and deploys a protective airbag to minimize injury risk, which also aim to ensure prompt assistance by triggering automatic notification to designated caregivers or emergency services. So this is the basic block diagram that we done. First, when the human movement signal is detected by the sensor, the microcontroller, which is the heart of the entire system, that is ESP8266, and when the sensor is detect when change in the human movement signal, when they are supposed to fall, the sensor sends an signal to the airbag inflator module, and the inflator will inflate the airbag Also, the caregivers get the GPS module through the GPS module, the access of the location, and also the notification message through push safer application. And we are also including a buzzer that the nearby to inform the nearby ones. This is also a detailed block diagram of our proposed model. And this is the expected model of the jacket that we are planning to design. This is the jacket when the before the jacket when the fall happens, and after the jacket when the fall is done. And these are the key features about the jacket design: a measurement of the jacket, the inflation mechanism. Upon detecting fall, the NOD MCU MPU 6050 sensor using that fall is detected, and there's an inflating pump or air module for inflating the airbag. Actually, the coverage areas of the jacket is the neck, that is cervical spine, and torso, that is chest back sides. And the main important, that's the spinal cord is also protected by this jacket. And the next, the main core functionalities of proposed model includes: first is the fall detection. The MPU 6050 is the main thing, the main sensor that is detecting fall upon fall is detected. So here, the algorithm could detect signals around 300 milliseconds before the fall is going to happen. The location also, when the fall is detected, the location is sent to the corresponding caregiver's phone through Neo 6M GPS module. And the next thing is the alert mechanism. You are including a buzzer that emits a loud sound to alert the nearby individuals for quick assistance and sends an automated notification message to designated contact. And next is the protective jacket. That's the main thing that we are designing. That is the inflator pump. Using the inflator pump, the jacket is inflated when the fall is detected. The jacket contains a cushion and which protect the individual from injury upon a fall. The entire process of signal detection, processing, and the relay activation typically occurs within 50 to 100 milliseconds. So the average inflation time is 0.12 seconds approximately. Combining all these, the entire thing is completed within 1 second. And this is the circuit diagram of the proposed model. So here we are using Neo 6M GPS module, MPU 605 sensor, Node MCU, airbag module, finally the air jacket, etc. And this is a flow chart. Here, when the here how the fall is detected upon the changes in the human signal, human being movement is when we set a threshold magnitude, and when the accelerometer magnitude is greater than this threshold, corresponding the sensor will detect that is the fall is happened, and corresponding signal is sent to airbag, and the airbag is inflated by through the inflator or airbag module. And finally, at that time, the GPS location and SMS is sent to the corresponding caregiver's mobile phone, and along with that, the buzzer will also alert the nearby ones. So this the methodology has for the methodology it has been done in two, that is software development and hardware development. So in software development, C++ programming language is used for used and is done in Arduino IDE platform. So the notification is given through the push safer application to the designated contact at the time of fall. And this is a hardware development. Hardware development step includes the assembling of the components such as MPU 6050 sensor, NOD MC USB 266 microcontroller, Neo 6M GPS module, buzzer, airbag for ensuring the proper connection. And here we already told about MPU 6050 sensors for detecting the fall, and Neo 6M for GPS access. And once a fall is detected, the microcontroller initiates a signal to relay, subsequently triggering the activation of the airbag module. Also, the buzzer is activated to provide an audible alert. So this is the interfacing of the Node MCU ESP8266 with MPU 6050 sensor, relay module, buzzer, Neo 6M GPS module. And finally, the integrating the software and hardware for getting the all these things in practical. So finally, by combining all these, we get the result from that objectives that from five objectives to develop an innovative fall detection system using microcontroller and MPU 6050 motion sensor. Here we are setting a threshold, and when the algorithms were implemented to process the data from the sensor and identified fault patterns, a threshold was established to differentiate normal activities from fault. The effectiveness of the fall detection is evaluated by testing under various conditions such as walking, sitting, falling to ensure the reliability. The values obtained from the Arduino IDE is plotted to form a graph that signal patterns. The highest peak represent the when the at the time of fall is detected. And the baseline measurements used are under normal conditions, fall even and pause fall. Under normal condition, the x, y, and z values fluctuates around small values. And when a fall has happened, there is a sudden and significant change in acceleration in one or more axes. This results in a sharp increase in the magnitude. And when after the fall, the person is immobile, the accelerometer readings might stabilize again, but at different values depending on the final position. And the objective two, the airbag system is designed to deploy upon detecting of fall through MPU 6050 sensor, microcontroller, and airbag mechanism. And the signal is sent to the relay module, and by power supplying the relay module, the airbag deployment mechanism happen. And effectiveness of the developed fall detection algorithm is is evaluated by experimenting on two subjects through backward fall and forward fall, and these are the measurements that I've got during the experimentation results. And by these experimentations, we get an conclusion that the triggering time of average, that is 0.6 seconds, is obtained for the proposed algorithm to detect fall is happen, and finally the inflation of the airbag system is happen.
Khadija, please conclude.
Yes,
Please
ma'am.
please conclude.
This is a final proposed jacket before inflation and after inflation. So this is the GPS location accessing, and finally the deflation of airbag system. So the conclusion is the project can make a significant impact on fall prevention, leading to safer and more independent future for many. And also a lot of future scopes on this project on advanced detection and enhanced interventions, personalized experience, and research and development. So that's all about my presentation. Thank you.
Thank you. Sorry, we had to hasten up because the time constraints are there. Although it is very interesting also. Perhaps personally, on my personal behalf of also, it is very interesting for my research area also. I too have plenty of questions, but I cannot put in them now in consideration to the time. And you have already few questions in the chat box. You can keep reading them. And we will take up other questions at the end of the technical session. Thank you, Khadija.